we need to continue our discussion of respiratory protection. In the last module, which was module 3, we finished discussing different types of respirators. We talked a little bit more about airline respirators. We talked about combined systems. Normally those combined systems are going to also, maybe it's an airline system with an SCBA system also. We talked about hoods, helmets, masks, loose-fitting face pieces, just to clarify our understanding of that terminology. In this module, I want to focus on respirator selection. I think it's very likely the most important part about using a respirator is making sure we have the correct respirator for the job that we're doing, and choosing the correct respirator includes choosing the right type of filter or gas cartridge, and we'll talk about that. But when we're choosing a respirator, there are several different options. You can use the PEL or TLV to determine the respirator that's needed. Again, PEL is OSHA's limit value, exposure limit. TLV is a voluntary exposure limit, and that's published by the American Conference of Governmental Industrial Hygienists. There's also the recommended exposure limit, which is also voluntary. That is published by NIOSH. A lot of times OSHA will go along with NIOSH, but generally speaking, the REL from NIOSH and the TLV, those exposure limits are more conservative. And really, the TLV of the REL is really the way to go if you're a proactive safety organization or safety program, and you want to make sure that you're doing the most you can to protect your workers. But having said that, PEL is the legal requirement. A lot of companies will just go with the PEL. That's all they're interested in, is complying with the PEL. And honestly, I think PEL most of the time is going to be fine. But if you really are proactive, look at the TLV or the REL. So, but we can use these numbers and some other numbers along with them to determine the respirator that's needed. You can also use the NIOSH guide, and I'll give you an example of using the NIOSH guide to select a respirator. That's a quick and easy way to go if it works out for you, but it doesn't always work out, as we'll see. You could also use the SDS sheet in some situations. In some situations, you're not going to be able to use the SDS or the NIOSH guide because the information's not in those materials. So you're going to have to do some additional research. You're going to have to look at other print resources or online resources, and make sure you're choosing credible organizations. Make sure the information you're getting is from a credible organization. Now, we'll talk about these 4 methods as we go along. And I'll give you some example respiratory selection problems that utilize all 4 of these different methods. You might run into situations, though, where you can't figure it out. And you want to make sure you're making the best decision for your workers. So in that situation, you contact a CIH or other respiratory protection expert. A CIH is the best, that's the highest level of industrial hygienist. That's a certified industrial hygienist. It's very difficult to become a CIH. So that would be a good person to contact if you can't identify without any doubt the type of respirator you need. Because, in some situations you choose the wrong respirator, you may end up with a seriously ill worker, or even worse, maybe a dead worker. That's what we don't want. We want to make sure we're making the right decisions. So never be too proud to call somebody if you're not sure. Contact chemical manufacturers. They may be able to provide you with information if you can't find it anywhere else. And you may have to look at multiple sources. And it's really like working as a detective in some cases. In the easy cases, you just go to the NIOSH guide and there it is right there for you. But in other cases, it's not so simple. And it's like working as a detective, looking at a lot of different pieces of information, talking to different people, and ultimately you're going to be able to find the right respirator for the type of work you're doing. Now, there's one concept that I need to cover that goes along with respirator selection, assigned protection factor, or APF. Also, hazard ratio. Actually, there's two concepts I need to get squared away before we continue. Both of these concepts can be very important for respirator selection. Now, the APF is a rating assigned to different types of respirators. If we have a respirator with an APF of 10, that means the air inside the respirator is 10 times cleaner than the air outside the respirator. Now, APF values, well, I'll show you a chart here in a minute with the different APFs for different types of respirators. But the APF rating ranges from 10 to 10,000. It used to range from 5 to 10,000, but I'm not even going to cover the quarter mask respirator. The quarter mask respirator has an APF of 5, but I'm not going to consider those because you shouldn't use quarter mask respirators. As we'll see in a second, again, like I said, the lowest is 10, the highest is 10,000. Along with the APF, we need to identify the hazard ratio. The hazard ratio is the concentration in the workspace divided by the TLV, PEL, or REL. Let me go ahead and put that in there. Again, you take your concentration, you've done some sampling, you know what your concentration is. You take that, divide it by whichever threshold limit you're using, exposure limit you're using, the TLV, the PEL, or the REL. The APF of your respirator must be greater than the hazard ratio that you calculate. Here's an example. After ventilation, the workplace concentration for substance X is still 400 parts per million. Again, they ventilated, but they're still at 400 parts per million with the ventilation that they've got. So they need to use a respirator because the TLV for substance X is 25 parts per million. What is the minimum APF for respiratory protection devices used by workers in this area? So we need to calculate our hazard ratio. And hazard ratio is the concentration divided by the TLV in this case. Again, we're using a TLV. So concentration is 400. The TLV is 25, so 400 divided by 25 gives us a hazard ratio of 16. The APF of the respirator must be at least 16. So let's look at our chart and find us a respirator that would be good in that particular situation. Okay, we need a respirator, or we need a respirator with a APF of 16 or greater. So the half mask air purifying would not work. The full face piece with an air purifying respirator would work. Okay, these are passive air purifying. There's no pump hooked to them right here. Now, a powered air purifying respirator would also work. So would with a half mask or a full face piece or a loose fitting face piece, loose fitting hood. We could also use a supplied air respirator in demand mode. Again, demand mode means that the rate of airflow is based upon your rate of breathing. If we have a demand mode supplied air system with a full face piece, that would work. We could use any of the continuous flow supplied air respirators or any of the positive pressure respirators, supplied air positive pressure respirators. Self-contained breathing apparatus, we could use all of those except for the demand styles SCBAs with a half mask. So that gives us a lot of options. Now we would want to choose one that was most cost effective. And the most cost effective is going to be a full face passive respirator, passive air purifying respirator. It's got an APF of 50. So, let me see if I can erase some of these marks I've made. Oh, there we go. That was easy. Go ahead and get my pen activated again. Okay, this is a chart that can be used to help us determine the type of respirator we need. If we know what APF we need, then we can go to this chart, and what we have here in the left-hand column, we have the types of respirators. Then we have the type of mask along the that upper row, and representing different columns. Half mask is this column, full face is this column, so on and so forth. So, a very useful tool. This is from OSHA, from an OSHA publication. I simplified it for our purposes. They actually had a quarter mask respirator in there. And again, quarter masks are, I don't know of any place that uses a quarter mask respirator. So I just completely left that out and came up with this new chart. There are a couple of notes here. Note 1, if you're using a helmet or a hood, you must have research documentation from the manufacturer stating it is 1000 APF. Otherwise, the APF is 25. And the chart for the helmet and the hood, here and here, you have two numbers. You have 25 and 1000. That means that you have to have research documentation from the manufacturer before you can call it a 1000 APF respirator. In most instances, it's going to be a 25 APF respirator. Now, any loose-fitting face piece is also the best you can do with a loose-fitting face piece is 25. Now, one thing, I'm going to double-check this and come back, because there should be an APF for a helmet or a hood with a positive pressure supplied airline. That might have been a mistake I made when I created this chart. So that is, I'm going to go back, I'll double check, and in the next module I'll verify. We'll look at this again, just very quickly verify that we're on the right track there. But again, this is an APF chart that can be very useful. Another note, this is kind of an important note. The air purifying half mask respirators, this includes the filtering face pieces. The N95, the P95, the R95 and above, those particulate respirators, the dust masks type things that we looked at earlier, those are actually considered an air purifying respirator, and they have an APF of 10. Again, all of this assumes that everything fits properly and the equipment is in good shape. All right, let's talk about another concept that we need to be familiar with when we're choosing respirators. The maximum use concentration, or the MUC. The maximum, what we're talking about with the MUC is the maximum contaminant concentration where a respirator can be used. It's something that needs to be calculated. It is the APF of the respirator multiplied by the PEL, TLV, REL, or any other exposure limit. Most times it's going to be PEL, TLV, or REL. But you take the APF, multiply it by the exposure limit for the contaminant, and that gives you your maximum use concentration. Here's an example. Workers are cleaning out the inside of a confined space, which previously contained substance X. The REL, or recommended exposure limit for substance X, is 10 parts per million. They are using an airline respirator with a loose-fitting hood. What is the maximum concentration in which they can work? Need to look up the APF for loose-fitting airline respirators. It's 25. Then we take the APF and multiply it by, in this case, the recommended exposure limit, which is 10. The maximum use concentration is 250 parts per million. The respirator would not be safe in concentrations above 250 parts per million. So what if the concentration is greater than 250 parts per million? Well, we would need to get a respirator with a higher APF. That would solve that problem. Now, another issue we need to keep in mind with regard to the MUC, sometimes the IDLH level is less than the calculated maximum use concentration. Always go by what the IDLH level is for a contaminant. And I'll show you an example here in a second, and I'll repeat this here in a second with that example. But IDLH always takes precedence over the calculated maximum use concentration. And if it's IDLH environment, you got to use an SCBA. Well, there's a lot of letters there. IDLH, SCBA, MUC. I'll just try to keep them straight best you can. All right, let's look at the procedure for selecting the proper respirator using the PEL or TLV or REL. The first step, evaluate the atmosphere in the work area. What is the hazard? What is the concentration? Use the PEL or TLV and the concentration to calculate the hazard ratio. Choose a respirator type having an APF greater than the hazard ratio. Calculate the maximum use concentration. If the concentration you're working in is greater than the MUC, you cannot use that type of respirator. You will need a respirator with a higher APF. And here's that note about IDLH that I mentioned in the previous slide. Sometimes the MUC will be higher than the IDLH level. IDLH level takes precedence over the MUC. If concentration is above IDLH, you must use an SCBA, a self-contained breathing apparatus. Okay, back up to this step-by-step list that we have up here. Okay, once we've got the right type of respirator, if it's an air purifying respirator, we need to choose the correct cartridge or filter for the contaminant. Maybe an organic vapor cartridge, an acid gas cartridge, an ammonia cartridge, or maybe the hazard is a particulate and all you need is a particulate filter. But you need to know what type of contaminant it is. And we'll talk more about this, and I'll talk about the different types of cartridges before we're done. And there are combination filters that are available that we'll talk about. Another point here, when you're using this approach to identify the correct respirator, the SDS may not be needed, but it can be useful. Okay, let's talk about respirator selection using information from the NIOSH guide. Okay, we evaluate our atmosphere or work area, the hazard, the concentration. Go to NIOSH and search for contaminant. As an example, I'm using acetone as an example. You can go to NIOSH and search for the contaminant that is of concern, the hazardous constituent that you need to protect workers against. In this case, we're using acetone as an example. And here are the respirator recommendations if you're working in an environment with vapors from acetone. Again, the IDLH level is 2,500 parts per million, SCBA required. But let's say it's less than 2,500 parts per million. So up to 2,500 parts per million, which would be less than 25 parts per million, you can use a respirator with an APF of 10 with organic vapor cartridges. Voila, there it is, simple. That's the type of respirator you can use. Again, that's the lowest APF. But if you want to be a little more conservative, and let's say your contamination level is getting close to 2,500 parts per million. Let's say you're at 1,800 parts per million, and you want to be a little more careful and a little more cautious. Well, you could use an APF of 25. which would be any powered air purifying respirator with organic vapor cartridges. Or you can go with an air purifying full face piece respirator, which using more of a military term, is a gas mask with a chin style front or back mounted organic vapor canister. Again, air purifying full face piece, passive. That gives you an APF of 50. Then there are other options as well. But what you'll want to do is choose the option that provides the protection and also allows or makes the most financial sense. You don't want to break the company if you don't have to. I'm thinking that the passive air purifying respirator with an APF of 50 is going to be the best option. It's going to be effective if it's worn properly, and it's not going to be as expensive as a powered air purifying respirator. It's not going to be as expensive as a supplied air respirator. It's definitely not going to be as expensive as an SCBA with a full face piece. Also, the NIOSH information includes what to do in emergency situations. Emergency or escape situations. Okay, that's a simple way to go. Now, what if we can't find any information in the NIOSH guide? We search NIOSH far and wide, we can't find anything. In that situation, we go to the SDS, possibly. Go to the SDS for the product being used. That SDS will have a list of hazardous constituents. And most products, or many products, may have multiple hazardous constituents. Write down those hazardous constituents, go back to the NIOSH pocket guide, and look up each hazardous constituent. For hazardous constituents not found in the pocket guide, which that's going to happen, do additional research. Go on the internet, look at some print resources, contact the manufacturer. One thing to keep in mind when you're doing this kind of research, many hazardous constituents have multiple names. For example, methyl ethyl ketone is also called butanone. And you may have to do some real detective work to find information for every hazardous constituent. And I'm going to be going through an actual example of this before we're done, because I think this is important. I'd rather overkill this subject than not say enough about it and you guys being lost in this situation. So some other variables we need to consider when selecting respirators. Work area characteristics. Is it a confined space? How hot or cold is it in the space? How close are we to clean air in this area? The type of work we're doing. Is it physically strenuous? Pay attention to how the area where you're working affects the fit of the respirator. Can an adequate fit be achieved for a tight-fitting respirator? Another variable to look at, how long will the workers be wearing the respirators? Also, you always want to consider the limitations of different respirators. All right, that's kind of an overview of the process. In the next module, I'm going to come back and we're going to walk through some more respirator selection problems. All right, I will see you in the next module.